Hello everyone, welcome to section 6.4 on stoichiometry. The learning objective for this section is to use stoichiometry to determine quantitative values related to chemical reactions in terms of both mass and moles. I also want to note that this is the last section that you need to complete in the first week of Module 6. And I'll also mention that the ideas from this module from this section will be the basis for everything in the second part of Module 6. So you will be seeing these again. You don't have to have them mastered by the time we meet for class, but I do want you to see them by that point so that we can address any questions you have, and so that you can be prepared for next week when you do part 2 of this module. Okay, so what is stoichiometry? Stoichiometry is the numerical relationship between quantities in a balanced chemical equation. So we have already discussed how to balance a chemical equation, and one of the things we can do with that information is use it to either predict or determine how much of a given product is going to form from a given reactant. So here we're showing a car. So the car runs on gasoline, and as the gasoline is used up, we have in our exhaust, we have water and carbon dioxide. So our car engine is turning the gasoline into water and carbon dioxide. And what we can do with this information is we can determine how much carbon dioxide is going into the atmosphere based off of the amount of gasoline that is sold in the United States. So we have that information. You could each do this calculation by the time we are done with this module. I want to start with an example based off of a recipe, because the same ideas we use in stoichiometry are the ideas you would use in using a recipe to make food. So let's say this is a recipe for pancakes. So if you have 1 cup of flour, 2 eggs, and a ½ teaspoon of baking powder, you could make 5 pancakes. Now your pancakes might be more exciting than this. We're just going to assume something pretty basic for now so that we can keep the math easy. What we can do with this information is we can treat this recipe as a series of conversion factors. We can say that 1 cup of flour is equal to 2 eggs is equal to 1/2 teaspoon of baking powder is equal to 5 pancakes. Now, when we say that, we're not saying they are the same thing. What we're saying is that we can convert between those. We can find whichever one we need based on what we're starting with. So we pick the quality that works for the problem at hand. Maybe we have 5 cups of flour and we want to use up all of that flour, and we want to know how many eggs we need to use up all that flour. Maybe we have a bunch of flour and we have a dozen eggs, and we want to know how many pancakes we can make. So we can use these as conversion factors. So I'm going to just talk about that second one. So if we have a dozen eggs and we know that 2 eggs makes 5 pancakes, we can make 30 pancakes. So I'm not going to write out the math here, but I think hopefully you can kind of walk through it with the words. So if we have 12 eggs and we have 2 eggs equals 5 pancakes, we would have 5 pancakes over 2 eggs. So 12 times 5 divided by 2 would give us that 30 pancakes. The math we're doing here is the same math we do in stoichiometry. So let's look at that. So in stoichiometry, we are looking at a balanced equation, and we can use the numbers in that balanced equation as conversion factors. So we can compare any 2 parts of the chemical reaction. We can say we have so much hydrogen, how much nitrogen would we need? Or we could say we have how much hydrogen, how much NH3 would be produced by that. So let's go ahead and look at a quick example of that. How many moles of N2 will react with 9 moles of H2? So I want you to go ahead and pause your recording, see if you can figure this out, and then we'll come back and go through the answer. Okay, so let's look at how we solve this problem. I'm showing the picture here, but we could also write this as a chemical equation, which might be more useful. So we have 3H2 plus N2 to give us 2NH3. Okay, so I'm going to go ahead and rewrite that part in there. And the question is, how many moles of N2, I'm going to underline that, will react with 9 moles of H2? So in this question, we have two things we care about. We care about the N2, we care about the H2. So those are the two things that we want to include in our conversion factor. In this particular question, we don't care about the NH3. In a different question, we might. So I'm going to write down 3 moles H2 equals 1 mole N2. Okay, so we have that information. That will be our conversion factor. And we have 9 moles of H2, so I'm going to write that down. And then I'm going to write a conversion factor here. We have 1 mole of N2 on the top, 3 moles of H2 on the bottom. Okay, we're setting this up so that the H2 will cancel out moles of H2, and we're left with units of moles of N2. One thing I want to note here, and this might be something you were able to sort of skip over in Module 5, when we do this, we don't just write moles. We have to include moles of what? Because as you can see, we have moles of N2 and moles of H2. And if we weren't clear here, it would be very easy to get confused with this conversion factor. So make sure you are writing H2, N2 in addition to the word mole. When we do the math, you have 9 divided by 3, so you get 3 moles of N2. Okay, so that is how we do that. Okay, so when we do this, we looked at an example with moles. The complication is that we don't have in the lab a balance or any kind of instrument that will tell us how many moles we have. We typically measure things in terms of mass, not in terms of moles. As we'll see later, sometimes we might measure them in terms of a volume, but we're not measuring them directly as moles. So we have to, in order to use this idea of the mole as a conversion factor, we have to first convert to moles. So we can convert between moles of one thing and moles of another if we have them in units of moles. But we first have to convert from mass to moles. There's not a direct conversion from mass to mass. We have to convert to moles first. Okay, so in general, the series of conversions that we will often see will look something like this. We'll start with the mass. We're just going to call this mass A. This is whatever you're given. You would use the molar mass to convert to moles for that substance. So this, again, we did in Module 5, so you know how to do that already. What we have just introduced is going from moles of A converting to moles of B using the ratio of the balanced equation. So we just looked at how to do that. And then you can take that moles of B, convert to mass using the molar mass of B. Each of these steps is something I am quite sure all of you can do. The challenge is when you put them all together, you need to think about how to set this up. So you don't have to do it all in one step, but when you put them together, it gets a little bit more complicated. So I want to look at an example of this. Okay, so actually, let me go back. I'm going to look at it just like this. What mass of NH3 can be made from 2.57 grams of H2? And I am showing the balanced equation for you there. You will probably also need to look at a periodic table. Go ahead and pause the video, see if you can answer this, and I will go through the answer key. Excuse me. So let's go ahead and talk about the answer key now. You'll notice that I have shown this at the top. This is showing a process you can use to solve this problem. If this is helpful to look at as we're going through this one, feel free to look at this if you haven't solved it yet. So maybe you could pause it again and use this as your roadmap. However, you won't always have this. This will not be on the exam. You'll have to figure out these steps on your own. But the first time we look at it, it's probably okay to have that little extra clue there. So what I'm going to do, I'm going to read through this and highlight what's important and then figure out what information we need. So we're looking for the mass of NH3. So if we need to know the mass of NH3, one thing we might want to know is the molar mass. So we can say 1 mole of NH3 is equal to how many grams? If you do the math there, it's 17.04 grams. So this number is from the periodic table. That's something I'm pretty sure you can all do. If you're not sure, go ahead and pause the video. Check that on your periodic table. So this is the molar mass of NH3. Can be made from 2.57 grams of NH2. I'm going to write that down, 2.57 grams. I'm sorry, I said NH. That's grams of H2. We might need the molar mass for H2 as well, so I'm going to write 1 mole of H2 is equal to 2.02 grams. Again, you can get this from the periodic table. So the two things we care about are H2 and NH3. Usually there's going to be 2. We'll see later what can happen where you might care about more than 2, but for today, it's just, or for this section, it will just be 2. So we look at the balanced equation and we look at how is NH3 related to H2. So we have NH3 here, we have H2 here, and the relationship is the coefficients in front of those substances in the balanced equation. So what we can say is 3 moles H2 is equal to 2 moles NH3. Okay, so this is the information that we will probably need. So the first step before you start trying to convert things and start trying to figure out what to do is to write down the equalities that your conversions will be based on. You will probably need 3. In some cases, you might only need 2, but I'm writing down 3 here. Okay, so let's start with the 2.57 grams of H2. We start with that because that is an equality. Because it's a number by itself. It is not an equality. We start with a number by itself if we can, most of the time. The first thing we do is we've got grams of H2. We want those to cancel, so we look for where do we have grams of H2. We have it right here, so 1 mole of H2 is equal to 2.02 grams. Let's use that conversion. So we put the 2.02 grams on the bottom. We put the 1 mole of H2 on the top.